Good afternoon to one and all. Today we are going to see a simple problem on the Gauss-Seidel method. As we have seen already some many problems, this is also a very simple problem. So if you get this sort of question, easily you can score marks, and this sort of easy questions may given they might be given in your 5 mark questions and half of the your request. Okay, so mostly 5 mark questions. So here two buses are given. So the impedances are given between the buses. Say for example, first bus and second bus, the impedance values are given, and the self-impedance Z11 also given, Z22 also given. Okay, so what is the first step? So we need to identify the slack bus. Next, find all the parameters of the load bus. Okay, so we need to identify which is the slack bus, and we need to find all the parameters of this load bus. Okay, and the next step is formulate the Y bus matrix. So Y bus matrix, you know. So Y bus matrix, 2 cross 2 matrix will come. Okay, so first we need to solve the Y11. Y11 is equal to this particular self impedance, and as well as this uh, Z12 that you need to okay add. Okay, so if you add 1 divided by 0.024 plus j into 0.105, because it is given in the question. Okay, this is the admittance y11. So the impedance values are given. So 1 divided. So this plus this value plus this value, that is 1 divided by this value Z11 plus 1 divided by Z12. So after simplifying, like y11 is equal to 7 minus 14.08. Next y21. Y21 or y12 is equal to 1 divided by that value, whatever the value given. Okay, so the same value that is being given. So the same value, just simplify it, you'll get the answer as 1.01 minus j into 5.03. Directly by scientific calculator, you can get this. Next to y22. Y22 is the combination of this both. Okay, this Z12 plus Z2. So y22 is nothing but 1 divided by Z12 plus 1 divided by Z2. Just to simplify, okay, take your scientific calculator, calculate it, and you can get the answer as y22 value as 3.57 minus j into 16.06. So here, whatever the value you got, that value you write here. So y11, whatever the value got, that value. Here y21 or y12. So minus of that value, whatever the value we got, minus of that value is the y21 or y12. Next to y22 value also we already calculated, that is 3.57 minus 16.06. Okay, so we formulated the Y bus matrix. Next step, what I'm doing is I am converting this imaginary format, that is complex format, into this polar format. That is what is the magnitude and the phase angle, like that. So in the calculator, in scientific calculator, you can find out this. Just you type this complex number and you find out the angle for this particular complex number in your scientific calculator. You'll get the value. Say for example, 3.07 minus 14.08 J. Okay, can be converted into 14.41 at the angle of minus 77.69. So this is the value you got it from the scientific calculator. Similarly here, y22 5.13 at the angle of 101.35. Similarly here, 5.13 at the angle of 101.35. Similarly here, y22 16.45 at the angle of minus 77.46. Next, step number 3. Assume the flat start profile, that is we need to assume the flat start. Okay, so here it is given in the problem, that is V1 dash equal to 1.05 at the angle of 0 per unit. That is given in the problem. What is the old value? So V1 that is 1.05 at the angle of 0 degree per unit, that is given in the problem itself. V2 old value not given. So you have to consider that as 1 at the angle of 0 degree per unit. Next step, P2 is equal to 0.3, Q2 is equal to 0.1. That is also mentioned in the problem. And alpha, the tolerance limit alpha is given as 1.6. And epsilon, okay, so epsilon value, this is the acceleration factor, not the tolerance limit. Acceleration factor alpha is given as 1.6. Tolerance limit is given as 0.0. So everything is given. Just say, for example, if you are programming it, easily you can program all this thing and you can get the answer. But now we are solving. Next, step number 4. For the iteration count, k is equal to 0, p is equal to 2, bus p is equal to 2, and q is equal to 1. Next, what is the formula for the load bus? Vp of k plus 1 is equal to 1 divided by ypp, pp minus j into qp divided by vpk star minus summation q is equal to 1 to p minus 1 ypq into VQ k plus 1 mu. Okay, the whole bracket. So here you know k is equal to, so star is nothing but conjugate of. Example, V2, V2 volt. So V2 volt you given in the problem is 1 plus J0. So star means minus 1 minus J0. That's all. So substitute all these things. That is 1 divided by YPP. That is nothing but Y22 P2 minus J into Q2 divided by V2 volt star minus Y here 21. Okay, PQ 21 V1 new. So here you substitute this 1 divided by here Y22 value. What is the Y22 value? Yeah, Y22 value is 16.45. 16.45 at the angle of, sorry, here it is mentioned above. So at the angle of 77.46. Next here P2 you need to substitute minus J into Q2. So P2 also given in the problem as 0.3, Q2 is 0.1. So V2 volt 1 minus J0, J0. Okay, because minus J0 has no value. So that we have taken directly as 1. Next minus Y21, Y21 5.13 at the angle of 101.35 into V1U. V1U mentioned in the problem as 1.05 at the angle of 0. So here, just a simplification, all you need to simplify, you need to convert. For doing this, you need to convert all into polar format or rectangular format, and you need to further, you need to solve. So V2 dash value, you get the answer as, sorry, V21 value, you get the answer as 0.331 plus j into 0.025. Before that, we got in the this form, polar form, that is 0.3314 at the angle of 175.53. Just what you need to do is you need to convert. You need to convert it into the polar format, and you simply, if you convert into polar format, you will get the answer like this. Next, what is the change in voltage here? V2 new minus V2 old. So what is V2 new? That already we calculated, minus V2 old. V2 old is mentioned in the problem. That is 1 plus J0. Simplify this, you will get the answer as change in voltage as minus 1.331 plus J into 0.025. This is the change in the voltage.